morning to one and all. I'm Venkatesham. I'm going to discuss about topic solubility product. Solubility product is purely depends upon the it's a solubility of a solid substance. We need to talk about what is the solubility. Solubility is nothing but the maximum amount of the substance that can be dissolved in 100 grams of a solvent or 100 ml of a solvent is it's a solubility. Solubility is the maximum amount of the substance that can be dissolved in 100 grams of a solvent or 100 ml of a solvent is it's a solubility, right? Generally ionic solids are there. These ionic solids are dissolved in water to the higher extent, right? Its solubility is high. Based on the solubility, salts are further classified into three types are there. One is soluble salts and its solubility is greater than the 0.1 molar, and second one is slightly soluble salt. Slightly soluble salt. This slightly soluble salts solubility is less than 0.1 is there, less than 0.1 molar, and third one is sparingly soluble salts. Sparingly soluble salts. Sparingly soluble salts in which there is a solubility is less than 0.01 molar. That means 10 power minus 2, less than 10 power minus 2 solubility containing salts, right? So based on the solubility, salts are mainly three types are there. One is soluble salts, slightly soluble salt, and sparingly soluble salt, right? Here saturated solution is one. It will be the saturated solution is nothing but a solution in which no more solute is dissolved. That means we are adding the excess amount of solute. That solute will not dissolve in the solution. Such a solution is a saturated solution. That means it reaches its saturation level. The solution reaches its saturation level. In that if you add excess amount of solute, that will not dissolve. Such a solutions are it's a saturated solutions, right? Solubility product can be defined as which is a product of concentration of the ions in solubility equilibrium. Suppose I am taking that there is an AB is one sparingly soluble salt, and for this sparingly soluble salt, and it will be dissociated into here A plus plus and here it is in a B minus, right? There exists a equilibrium between the A plus and B minus and AB molecule. Such a equilibrium is it's a solubility equilibrium. In the solubility equilibrium, solubility of this particular A plus is yes, and whereas in a B minus also yes, right? So here a stoichiometric coefficient of A plus is 1 and a B minus also 1. When we are writing it's a solubility product and its a solubility product is KSP. KSP is equals to here product of A plus ion concentration. Here its a stoichiometric coefficient will be raised to the power, and here B minus ion also its a stoichiometric coefficient will be raised to the power. Here nothing is there means 1 is there, so that I can write here S into S. So from that I can write here KSP is equals to it's S square is for AB type of electrolyte it's a solubility. This it may be a univalent or it may be a bivalent or it may be even trivalent. Also it's a solubility product is that is an S square only. We can write KSP is equals to S square, right? In this solubility product and here solubility product, so that can be defined as a product of concentration of ions in the solubility equilibrium, and the stoichiometric coefficients of the ions are raised to the powers while writing its a solubility product. Generally this solubility product can be represented by a symbol KSP, right? KSP is simply it's a solubility product. If I will take AB is a general form of electrolyte and salt, and it's a univalent. Even in A plus and B minus is there. It's a solubility S and S, and KSP you will get. Even for the this AB type of electrolyte, even I can write AB that can be dissociated into it is A plus 2 and even B minus 2 also. Its solubility S and S only will get, and again you will get the solubility product KSP equals to S square. If you will take this AB type of electrolyte again, if it is A plus 3 type of and B minus 3, that means this is a divalent AB type of electrolyte, and trivalent AB type of electrolyte also. Again you will get its solubility product is that is in KSP is equals to S square, and from this I can write its solubility S is equals to square root of KSP is its solubility, and solubility S is equals to square root of KSP. Here, and the second type of electrolyte is that is an AB2 type of electrolyte. So whenever I am taking this AB2 type of electrolyte, it will be dissociated into it's a plus 2 plus it is in 2B minus. So its a solubility of A plus 2 is a S, and it will become as a 2S, and it's a KSP solubility product to KSP. I can write down now. This is a plus 2 ion concentration into this is a B minus ion concentration whole power. Stoichiometric coefficient will be raised to the power now. So this stoichiometric coefficient is 2, it will be raised to the power. It's a stoichiometric coefficient here 1 is they will write power 1, and this is simply S, and this is a 2S whole power 2. That means you will get this is a 4S cube is it's a solubility product. Here KSP is for AB2 type of electrolyte, and 4S cube is it's a solubility product. From this I can write its solubility is equals to it's a square root of or cube root of KSP divided by it's a 4. KSP divided by 4 is it's a solubility. Here are some examples for this AB2 type of electrolyte, like calcium fluoride CaF2 and nickel hydroxide NiOH taken twice. Are some examples for the AB2 type of electrolyte, right? In the same way, if I will take this AB3 type of electrolyte, so here AB3 type of electrolyte that will be dissociated into here A plus 3, and this is a 3B minus so its a solubility is a S, and this will become as a 3S, and its a solubility product KSP is equals to here A plus 3 ion concentration into this is in a B minus ion concentration whole power 3. This stoichiometric coefficients will be raised to the power, and its solubility is a S, and its solubility is that is in a 3S whole power 3. Right. So here you will get this is simply KSP solubility product KSP is equals to 27 S power 3, and you will get 27 S power 4 is it's a solubility product for the AB3 type of electrolyte. Or you can write even solubility S is equals to this is a fourth root of it's a KSP divided by it's a 27. The solubility will get as a KSP divided by fourth root of KSP divided by 27. You can take some examples here. There is an aluminium hydroxide AB4 type of electrolyte, and that will be dissociated into it is a plus 4 plus this is in a 4B minus, right? This is a solubility S, and this is a 4S, and it's a solubility product KSP is equals to, so this is a plus ion concentration into, and this is in a B minus ion concentration whole power 4. This stoichiometric coefficient will be raised to the power, so that I can write this is a S into this is a 4S whole power 4. So that means you will get this is a 256 so S power 5. This is a solubility product KSP. Here KSP is equals to, so that is in 256 S power 5. Even solubility S is equals to and here fifth root of here Ksp divided by it's a 256 is a it's a solubility mass A3B2 type of electrolyte, and it will be dissociated into, so this is a 3A plus 2 plus 2, that is in B minus 3. So this is a solubility is a 3S and its a solubility is a 2S. So A3B2 3A plus 2 and 2B minus 3, right? And its a solubility product to Ksp is equals to, I can write this is an A plus 2 ion concentration whole power 3, here it is in a B minus 3 ion concentration here whole power 2. So here A plus 2 ion concentration is that is a 3S, its a solubility is a concentration molarity and equals to the its a solubility ma. That's the reason we are writing here this is a 3S whole power 3 and this is a 2S whole power 2. So that is 27 into 4 and 108 that is a S power 5. It's a solubility product Ksp is equals to, we'll write this is in a 108 S power 5, or you can write even solubility S is equals to, that is in a fifth root of it's a Ksp divided by it's a 108 ma. This is a simple solubility formula for the A3B2 type of electrolyte. For even in the this is a A2 and B3 type of electrolyte also you will get the same, that is in a here 2A plus 3 and this is in a 3B minus 2. So you will get a solubility here 2S and this is a 3S. Again you will get this is a for the same Ksp is equals to 108 S power 5. For this also this one and this one will be the same general form like a AX and a BY type of electrolyte. AX and BY type of electrolyte, it will be dissociated into, so X into A plus Y plus Y into B minus X, right? So X into A plus Y into B minus X. You can take its solubility as a XES and this you can take it as a YS, right? And its solubility product Ksp is equals to, I can write this is an A plus Y whole power X, this is in B minus X whole power Y. Okay, so this is a plus Y and whole power this stoichiometric coefficient X will be raised to the power, yes, stoichiometric coefficient Y will be raised to the power. Okay, so that's the reason I will write this is a XS whole power X and this is in Y solubility S whole power Y. So that I can write here solubility product of Ksp is equals to, this is a X power X and Y power Y and even solubility S power X plus this is a Y. So this is a simple one and it's a solubility product for the general formula AX and BY type of electrolyte. Temperature is increases then its solubility will be increases, then its solubility product to Ksp also increases. As the temperature decreases and its solubility will be decreases and the solubility product Ksp also and its decreases, right? So from this I can write here Ksp is directly proportional to the its temperature and this is one solubility product Ksp is directly proportional to its temperature. And ionic product this is it is simply a product of concentration of ions in the solution, right? And it can be represented by a symbol Ki. There is a relation between the its solubility product and its ionic product. Ksp is equals to the its Ki, then the solution is which is a saturated solution. If the solubility product Ksp is equals to Ki, then it is a saturated solution. If there is no question about precipitation here. Saturated solution, when we are adding the excess amount of solute also, that will not dissolve in the saturated solution. If Ksp is greater than the Ki, then that solution is unsaturated solution. In this unsaturated solution, there is a more solute can be dissolved, and the solution does not reach its saturation level, and if you add excess amount of solute, that will be dissolved in the solution, right? And another case, here KSP is less than the Ki, and here solubility product is less than the its ionic product, then the solution is it's a super saturated solution. In the super saturated solution, there is a precipitation can be takes place, because there is an ionic product is dominating, ions concentration is more, and here precipitation can be takes place. Here precipitate is going to be formed. There is no precipitate formed in the case of saturated solution and unsaturated solution. These two conditions, there is no precipitate is going to be formed. Whereas in the case of here ionic product is dominating, then it's a solubility product. That's the reason here precipitation takes place.